Hello Stormwater designers, welcome back to Clear Creek Solutions instructional videos, and today we're going to be doing an overview of stormwater infiltration. So this is a good beginner rudimentary video explaining what stormwater infiltration is, what are the factors affecting it, and just a basic overview of the concept. So stormwater infiltration is the downward movement of rainfall from the land surface into the soil profile and is a fundamental hydrologic process that reduces runoff, recharges groundwater, and supports ecosystems. So in this video, we'll look at why infiltration matters, the factors that affect it, and how engineers represent it in models such as EPA-SWMM. We'll also highlight three major infiltration methods used in practice, which is Horton, green-amped, and the NRCS curve number approach. So what is infiltration? Well, when rain falls, some of it runs off directly into gutters, ditches, and streams, but a portion infiltrates into the soil. This process reduces the volume of surface runoff and helps replenish local groundwater aquifers. As water infiltrates through the soil layers, it is naturally filtered, which improves water quality by trapping sediments and pollutants. Infiltration also plays a vital role in sustaining ecosystems by supplying moisture for vegetation and contributing to base flow in streams. Without infiltration, cities would face higher flood risks, degraded water quality, and the loss of stable stream flow. So why exactly does it matter? Well, it plays multiple roles in stormwater management. It lowers flood risk by reducing peak flows. It helps control erosion, improves water quality by soil filtration, and replenishes aquifers that feed streams and wells. Designing with infiltration in mind is also a cornerstone of low-impact development and green infrastructure. So what are the factors affecting infiltration? So how much water infiltrates depends on local site conditions. Sandy soils allow rapid infiltration, while clay restricts it. Vegetation protects soils and encourages infiltration, while compaction from construction reduces it. Soil that starts dry can initially absorb more, but capacity declines as it saturates. And finally, the slope matters. Water on steep ground tends to run off before it infiltrates, as opposed to more flat ground. What are some basic infiltration curve information? Well, we know infiltration rates change over the shape of the runoff hydrograph. So infiltration rates are typically highest at the beginning of the storm when soils are dry and they have more capacity. And as pores fill with water, infiltration slows until it approaches a stable minimum rate, often called the saturation infiltration capacity. These changing rates shape the runoff hydrograph, how quickly and how much stormwater reaches drains and streams. And while this can be somewhat accurately summed up in single event methods such as the rational method and NRCS runoff method, in continuous simulation, because of the time setup, continuous simulation does a better job at analyzing and looking at how the different soil layers will change over time with more rainfall and infiltration. If you want to learn more about continuous simulation, you can find videos like that on our channel here. So let's look at the Horton infiltration method. The Horton method, which was proposed in 1933, models infiltration as an exponential decline from a maximum initial rate toward a minimum constant rate. It's empirical, meaning it's based on observed behavior rather than soil physics. SWMM includes Horton and a modified Horton method, making it simple to apply when detailed soil data isn't available. The green-amped model is more physically based. It accounts for suction at the soil surface, porosity, and hydraulic conductivity. It assumes a sharp wetting front between saturated and unsaturated zones. With the right soil data, green-amped provides more realistic results than Horton, and EPA-SWMM implements this method, adapted from Mine and Larson's 1973 work. Then there's the curve number method, which can be common in design reports. The curve number method, developed by the USDA Soil Conservation Service, now known as NRCS, estimates runoff from rainfall events based on land cover, hydrologic soil group, and antecedent moisture. It directly computes how much rainfall becomes runoff, making it widely used in stormwater design reports. SWMM reports curve number for projects where regulatory agencies specify its specific use. So EPA-SWMM allows engineers to choose Horton, green-amped, or curve number methods depending on the project and available data. Each method influences hydrograph shape, peak flows, and overall water balance. For critical projects, calibration against observed field data is actually recommended. So let's talk about the real-world applications of infiltration. Infiltration modeling guides the design of many stormwater practices. Rain gardens and bioretention/bioswales depend on infiltration to capture runoff. Permeable pavement allows rainfall to soak through instead of running off, and detention and retention ponds are sized partly by accounting for infiltration losses. In some cases, infiltration projects are built solely to recharge groundwater, and many LID regulations explicitly require engineers to document infiltration in their models in some form. Now, there are some challenges and limitations, however. Infiltration models come with many of them, and soils vary across the site, and construction compaction often reduces capacity. Systems like permeable pavements can clog over time without maintenance, and seasonal differences such as frozen ground or very dry conditions also affect results. And without field testing, engineers often have to rely on estimated parameters. That's why calibration and maintenance are critical parts of infiltration design as a whole. So that is an overview of infiltration. You can see the works referenced here. We also have a free EPA-SWMM course if you're interested, in the description down below. It's a 24-video course that walks you through how to use EPA-SWMM, how to model in the software, and get started overall. So you can find that course for free in the description link down below. We thank you so much for watching this video, and if you have any questions, please leave it in a comment. Thank you so much for watching, and anyways, we will see you guys next time.